Are we supposed to talk now? We are supposed to talk now. Say hi to the people, Mark.
Hello, people. Welcome to Mark and Mark. My name is Mark.
And my name is Mark. We've been doing this for a little while. Basically, I'm the cloud gnostic. I use the cloud because I'm cheap, you know. But I'm a little scared of it. Whereas my good friend, Dr. Russinovich, as you know, he's really into the cloud and stuff. And so we're going to talk back and forth. He will be doing most of the talking because, well, he's prettier. Okay, that's the first thing. How many of you have seen any of our previous Mark and Mark sessions?
Oh, quite a few.
Well, I'm going to say that looked like about 20%. That was all. Wow.
That's still quite a few.
And we've been thinking that we were popular. So we should start out by asking, are these guys using?
Yeah, let's get a feel for the audience here. How many people have some cloud deployment right now? They're directly involved with one.
That'd be Office 365, Gmail, Amazon Web Services,
Salesforce,
cloud services in Azure, that sort of thing.
vCloud,
Office 365. Yeah, okay.
And Rackspace doesn't count.
No, you know what doesn't count? Dropbox, and I'll tell you why.
Why?
There's a class of cloud that I call GWAX, which stands for G, we're a cloud. And if you're an FTP site with a web front end, you're not a cloud. You're an FTP site with a front end, Dropbox. So, I'm sorry. Is there anybody here from Dropbox? No? Let's talk about them. So my job is to kind of move things along here, and I only say that because in the evaluations, when we get like 1,000 evaluations, two people will say, Mark Minasi should never talk. Dr. Russinovich should talk all the time.
Which isn't true. I think it's important that Mark's here because he represents somebody not like me that's got a vested interest in a cloud service provider and promoting the business of the cloud. So he's the straight guy representing you. And
that was the kind answer. The real answer is that if I'm not here pushing him along, we're going to do one topic in 75 minutes. So, because he has a big brain and knows lots and lots and lots of stuff. So, let me ask, how many of you would never use the cloud? Like you're convinced it's all right? Really, we have only a few cloud gnostics. That's really, really interesting. So we saw that a big percentage of you, somewhere over 60. How many of you think you're going to some new cloud service in the next year? That's a lot. That's a lot. I saw a really interesting number. IDG did a survey in November 2014, which was done quite well. I mean, a lot of web surveys are not done well. I used to study this stuff when I was getting my PhD. And one of the questions was, how many of you have no on-premises IT equipment at all?
Yeah, and the answer to this one.
No. You were saying last night.
Yeah.
I don't believe 16%. And another 4% said that they were going to be there. So a fifth of these organizations. Does anyone here have no on-premises IT stuff? I'm guessing if you go to Ignite, okay, a few of you.
Wow.
I'm guessing this is a biased audience. So I mean, if they're here for Ignite, they probably have Windows servers, right? You know, so. Okay. So since only about a fifth of you have been here, why don't we start off with a question that's kind of a basic one. It's a real simple one that is always worth revisiting. Well, why cloud?
Yeah.
Why the cloud?
That's a good question. How many people think that the cloud makes sense because of cost? You're going to save money by going to the cloud. How many people think it's another reason? And actually, my personal view, and maybe you disagree with me on this one, cost-wise, and I get this from some customers that come and say, you know what, we've got an on-prem infrastructure and it's just great and humming along. And so, yeah, we're thinking about the cloud in the future. Maybe it'll make sense. But for right now, we can maximize our dollar on-prem. We spend less on compute cycle than we'd spend if we went to the cloud. And the answer that I got to them is that's not what the cloud is. It's not really just pure dollar savings, although the kinds of scale and efficiency and supply chain economics of the cloud will ultimately make it so that you can't compete on a cost basis on infrastructure with the cloud. But ultimately, the thing that I think is driving people to the cloud right now, it's one word, and that's agility. And I know that sounds like a marketing phrase, but it really is the power of the cloud. It's self-service, on-demand, elastic scale, that lets you do stuff way faster than you were able to do it before. And that, even if you don't believe in it yourself, your competitors believe in it. And that's going to force you to wake up and realize that you got to do it yourself.
Well, I guess you're supposed to be arguing, but I'm agreeing with you because the way that I normally say it is you come for the cheap. I really would argue to you, Mark, that The people that I know who went to Gmail, went to Office 365, and I don't know how big those are, but those are, when we're thinking those kinds of services, they're doing it for the cost. Yeah. It's simply because, I mean, for me, you know what I do. I've been doing it for 32 years. At one point, I had 50 people working for me, as you did. You had a large organization at one point. I don't need them anymore.
Yeah, so I agree. I think a lot of these companies do recognize that they can't do it as cheaply and efficiently as going and using it as a service, whatever as a service. But there are, I say, still companies that believe, and IT pros that believe, I can do it cheaper myself because I can optimize my infrastructure for my own needs. And I can go on bare metal, and virtualization costs me money. I've heard that one too.
Really?
Yeah.
Huh.
Anybody believe that? You can save money by being physical versus virtual? No?
Well, you do save all that money on heating. All those computers that are humming away, heat the room. So.
Yeah.
But other than that, I say that people come for the cheap, but if they're smart, they stay for the agile.
Yeah.
I mean, my agile example that I like, I used this the other day for those who saw me in the talk, is I think of the guy who does the Sports Illustrated website. You got to know that Sports Illustrated's been around since like the 50s or something like this. And I figure their activity is about like this, But then there's 1 month every year.
Which month is that?
Well, back in the 50s, pornography was not as easy to get to as it is today. And so they'd have the bathing suit issue, which has nothing to do with sports. But I am imagining the web traffic goes like that. So imagine if they had to go buy hardware for this much, and they're only using it for 1 month.
So that's the elastic scale part of it, right?
Right.
But the agile part, here I've got another example that really highlights the agile, and that's a company that works on Azure, that's deployed on Azure, a partner called Towers Watson that does risk financial analysis and reporting and market position analysis. And they get data from the markets over the course of the trading day, and then they pump it into their analysis algorithms to set positions for the next morning. And they also sell this as a platform for their customers as well. And their customers, when they're doing on-prem infrastructure deployments with fixed infrastructure that their budgets would support, come up with the answer and shoot for having that answer in 8 hours based on the infrastructure they build out. When they go to an elastic scale cloud like Azure, at the end of the trading day, they go burst out their compute and they scale out and they get the answer in a fraction of the time they could on their on-premises environment, because you can scale out way broader, more cheaply than you can with on-prem infrastructure that you have in place. And so they come up with the answer in an hour instead of 8 hours. And what they do is not actually save money. They go turn around and take the answer that they got in an hour, and they feed it back into the system and refine it and get a better answer, one that's more accurate for the next morning.
They can do more what if.
They can do more what ifing. And so they're actually spending more money on this than they were before on their on-prem, but they're getting magnification on the return for their business. So that's the business value is what they're getting out of it. And that's, I think, a really crystallizes the example of agility.
I like that. Did you hear the JPL story along these lines?
No.
So the Cassini probe, you've heard of this Cassini probe, went out to Saturn back in '97 or something like that, and did a lot of cool stuff, and it takes all kinds of great pictures. I mean, you see this stuff, and it's like, I don't mind paying taxes, right?
Yeah.
And so at one point, like 180,000 pictures got streamed down from Cassini. Why? Was there a internet problem? Was Cassini downloading Windows 10? I mean, why was there this slowdown? I don't know. But so they got this big blip of them. And JPL, the guys who do this, had reckoned, I think, that it would take their servers 2 weeks to process these images. So what NASA decided to do instead was to spin up a bunch of virtual machines on some cloud service. And
we'll talk about later.
Well, yes, some cloud service. We won't mention all else. And so they got it done in 20 hours. Sorry. They got it done in 5 hours, and the whole thing cost $20.
Yeah.
Astounding stuff, I think they just didn't know about Azure infrastructure service, whatever. Sorry.
They must not have.
Yeah. All right, good. Yeah. So we were, the disruptive comes from, I forget what you called the talk. I think it was just Mark and Mark talk about the cloud or something like that. Anyway, but Tech Ed is different from Ignite, because in Tech Ed, the marketing people don't rewrite the titles without asking you. And so I got on the site about a week or two ago, and I said, Mark, where did you get that disruptive title from? And he said, wait a minute. Type. Oh, God. So But I kind of like it. I kind of like it because, you know, ultimately I have some thoughts, and you do too, about there's good disruptive things about the cloud. What do you think along those lines?
Well, as far as the good disruptive things, I mean, this agile that we've been talking about, the software and systems and processes and cultures that we've had in place have been designed for the previous way of the previous era of IT infrastructure, a much more static kind of environment, monolithic, large applications, the 3-tier SOA apps, the development life cycles, the infrastructure build-out life cycles. They go and order servers a few months in advance of when you're going to deploy the application. Once you get them in place, they're kind of frozen for a while, and you babysit them and take care of them like the pets. And we're moving to a world where things are very fast. You spin things up instantly. They're ephemeral.
I don't know if these are server people. Tell them the pets.
The pet story. Yeah. Well, so how many people have heard about the pets versus the pets analogy here? So the pets analogy here is the way that we've traditionally treated our servers in on-prem world, which is we use GUIs to install them, software on them, and once they've installed, we continue to accrete configuration to them, and at some point we forget how to even recreate them, and so they become our little precious that we have to make sure.
Managing pets, we take a lot of work to do this. We name them. Managing cattle, we don't name them, and that's important, you know?
We eat them.
We eat them, exactly. We just set them down a little chute, and bang, 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 they're, you know. They're hamburgers. Now, we would never do that. We call our servers Fluffy or something like that. You can't eat Fluffy. You're just not human if you can eat Fluffy.
But you can eat 1, 5, 6, 7.
You can. You absolutely can. And we probably did for lunch.
Yeah.
Although, was there meat? Was that actual meat?
I don't know. Was there? Did anybody think that was meat?
Never mind. So, I think they're disruptive for a couple of reasons. One is, we have all seen IT departments that are dysfunctional. You know, if you've ever seen the IT crowd, you know, from Britain, or there used to be a website about the bastard operator from hell or something like that. And what was the guy from Saturday Night?
What? No, I don't know.
Nick Burns. Oh. Move, right? Oh, the software's stupid. Maybe you're stupid. You know, we've all met those IT people. And in organizations that are driven by profits, those IT, you know, or have interesting work rules, these guys last forever. The cloud is an excuse to get rid of them. You know, you're in a hospital, local government, whatever the heck it is, where there's just been this entrenched, really not useful IT staff. Here's an opportunity to clean house.
Yeah.
That's one. The second one is, and you've written a lot more software than I have, so I may be wrong.
That's a little bit of an understatement.
There's a backstory here. In 2006, new feature comes out in Windows, an interesting one that normally he would write a utility for. He, however, has just been acquired by Microsoft and is busy counting his millions, you see. I'm like, Mark, you're going to build a utility? He's like, yeah, eventually, whatever. Cha-ching, cha-ching. So I taught myself C++ and I wrote the utility. He's been mocking me about it ever since. So,
if you want to call it a utility.
You want to twist that? Anyway, so, but you know what? And how many of you ever built an app, a large app, large piece of software? When you're finished, it's like it's actually done. To me, the first thing I think is, oh, now I have to throw it away and start all over again because now I know how to do it. Does that resonate at all?
It's definitely software engineering 101.
Yeah, exactly. But plan to build it twice, right?
Yeah.
You know, and the thing that's huge here is that the cloud offers us great things. I'll give you an example. If you are running servers, you probably know that you should be getting rid of NTLM. Have you heard that before? If not, it's true. It's not easy to do. It's okay, you need server 2012 R2, you got to play with silos. It's not the simplest thing in the world, but it can be done. In the cloud, there's no NTLM. If you're building an Azure cloud service, it's built on technologies. Windows Server is great, I love it. Windows Client is great, I love it. But these things were invented in the 80s, and there's no way that you can turn this stuff off without causing big backward compatibility issues. The beauty of the cloud is what? It didn't exist a couple of years ago. And so it's all modern stuff, and the churn rate, you know, the rate at which it changes is insane. So that seems to me to be a good disruptive thing. Which leads me to my next question. So if we're going to build an application, because there's different ways to use the cloud, we can take regular old server and stick it as a virtual machine, and that's great, but we're still stuck with the 1980s technology that's lurking in the back of it.
Yep.
If you want something entirely new, what is it? What kind of things can you do in Azure to let you do that? What's that called? In Azure what?
Yeah, well, let me actually build up to that one.
Oh, okay.
Because this is a journey that companies go through when they start to move to the cloud. They say, we're going to move to the cloud. And one of the things that we talk about, one of the ways that companies talk about moving to the cloud is something called lift and shift. How many people have heard of lift and shift? Which is just, I've got some stuff here on-prem, some servers, and I'm going to just lift it up and deploy it again, the exact same thing in the cloud, and just keep it humming along. And we started with a lift and shift kind of mentality inside of Microsoft. The way that Azure interacts with Microsoft IT, we treat Microsoft IT as the canonical large company IT organization. And we want to treat them like that rather than being part of the same company where they get special secret sauce and we do special things for them. But let's really treat them as somebody we can learn from and interact with very tightly so we get a tight feedback loop with them. And one of the things that they came to us and said, kind of recognizing on their own, is that lift and shift doesn't really save them money. That they realize for anything important, so yeah, there's a few rinky-dink stuff that can free up some servers by lifting and shifting it, and it's not worth spending any money on revamping that application, but for anything important, they talk about modernizing it as they move it.
Really?
Yeah. So one of the ways that people talk about modernizing this course, if it's on an old version of Windows Server, move it up to a new version of server in the process that you're moving it. But more fundamentally, the way that you're going to get benefits out of lifting shifting, here's a very simple example for it, is the applications that are used only during business hours. And those applications, you talked before about building out that infrastructure there for the peak demand, and otherwise those servers are sitting idle for the overnight, is in the cloud, you put them in virtual machines and you put auto-scale rules on it so that it scales out during the day, or it runs during the day and you shut it down at night. And once you're shutting it down, you're not paying for those resources anymore because it's pay as you go in the cloud model. So you fundamentally save money, even if you don't re-architect the app. Ideally, you re-architect it and you go to something called Platform as a Service, or PaaS, which is what you're talking about, which is you take advantage of...
Hang on, can I stop for a second? So you're saying, if I do a lift and shift, that there's an auto-scaling capability of some kind in your Azure virtual machines that make it easy to say,
yep.
It's terrific.
Right. Yeah.
So what does it, change the processors or something like that, so it's less per hour, or what?
It scales, well, so this is scale out. The auto-scale means create more virtual machines. So if you've got a web tier that's effectively stateless, you can scale it out and scale it down.
So at noon, I'm running 20 virtual machines. At midnight, I'm running one.
That's right. And you can do that with infrastructure as a service, so it's more tricky to write the software that deals with, machines being added to the domain and being deleted from the domain or starting up. Much simpler to take advantage of a modern cloud application platform, which we call Platform as a Service, which is designed just exactly for that kind of pattern. Because so many cloud applications are this kind of very elastic model where you want to scale them out, scale them down, treat the things as cattle, not pets. And so that's where something like Platform as a Service comes in, which is you write to this runtime API, and the thickness of that API, it can be very low level. So Azure's got this cloud service, Platform as a Service, very low level, very minimal changes to the application to take advantage of it, all the way up to more thick kind of Platform as a Service, like mobile apps or web apps, for example, which you're writing to a very thick runtime and you have little control. The platform's doing a lot more for you, but you're taking advantage of the productivity that it gives you. So all the patching of the runtimes and the APIs and the auto-scaling is all transparent to you. The fact that this website's running on 100 VMs versus 10 VMs, you don't worry about that. You just say, specify some rules about how much you're willing to pay per hour to scale it out, and it does it for you.
So the one Azure has is Azure Cloud Services.
Well, it's got a few. Like I mentioned web apps too is one. And then there's verticals like machine learning and Hadoop, HD Insight. So some verticals in different areas optimized for specific scenarios. In the general compute category, there's cloud services and there's app service, which has a bunch of verticals on top of it as well, like web apps and mobile apps and logic apps, for example. And those are different from the cloud services how? A little more specific, refined? They're more specific and refined for a particular type of scenario. So logic apps, for example, let you connect different APIs together and basically create workflows like suck this data from a Twitter feed and then plumb it into this email notification service and kind of logically flow the data through the system. So very oriented to a specific type of workload, and so it restricts you in type of code and functionality and logic you can bring yourself. Also restricts you in terms of the runtime support for that code. Whereas the cloud service, a lot more low level, so you can choose to install things in the OS and create admin accounts, even domain join those machines.
Oh, really?
Yeah, so it's kind of a thin veneer on top of the basic virtual machine.
But my understanding with the cloud service, because that was the first thing. When you and I started talking about Azure 5 years ago, that was about all you could do was build a cloud service. If I recall correctly, the idea is that you're basically coming from a model of ASP.NET, which I think everybody's probably heard of. But my understanding is, and tell me if I'm wrong here, is that I've built a few web applications, and this notion of being able to throw on a third or a fourth or a fifth web server quickly is not as easy as it sounds. It's certainly not if they're physical machines running Windows Server. My understanding, though, is that with a Azure Cloud Service, even though it's a glorified ASP.NET app, if you follow the basic rules, you automatically get the agility.
Yeah, you automatically get that scale out. You for availability and for scalability, and you automatically get rolling updates, for example. So you want to patch the code, then the system will orchestrate a patching process whereby it will only take down a certain number of them at a time, so the website remains active. And then you've got software load balancing on the front, which is taking those VMs that are being patched out of rotation, putting them back in rotation, all automatically. The system's taking care of that. So that's just...
And that's great. So you're doing a little bit of development, and you're getting all those benefits that you're talking about. But I've talked to people about this, and they said, PaaS, I'd never do PaaS. I said, well, why? Well, you're building a piece of software here that you can't run on a regular old computer without some real special stuff, which means once you come to depend on it, and you love the scalability, and it's terrific, what have we done? We've gotten locked in with a vendor. Yeah,
we hear the lock-in question. How many people are concerned about cloud lock-in in here? I'm sure there's some hands going to go up. Yeah, some hands went up. So there's, actually, I think that when it comes to what people really want is application portability. And there's a number of different reasons they want application portability. Avoiding cloud lock-in is one of them. Like, I'm bound to the APIs in this particular cloud. Now, if I want to take my app and take it someplace else, maybe I've lost confidence in the cloud provider, or the cloud provider is not operating in a place that I need to run my app, or I decide that the prices are going up. And you know what? I want to be protected against that. So I want to be able to take my app out pretty easily at some point. So we hear this from customers that want to avoid cloud lock-in, and we've taken that to heart. But there's also the other example where customers, lots of enterprises come to us over the last few years and they say, I want to write a new app. I know this cloud thing is happening. Tell me what kind of architecture I should write this used for this app, because I don't want to have to go rewrite it in 3 years or 5 years. I want to make it last through this new cloud wave. So tell me the cloud modern way to architect this app. And they want to learn to do that, but they want to run it on-prem because they're not ready to move that application to the cloud, or they want the ability to move it back and forth from the on-prem to the cloud. And so they're looking for that portability, not just for lock-in reasons, but for other reasons as well.
And the answer, I think we saw at the keynote, I was quite surprised to hear, was Azure Stack. That's what it's called,
right? That's right, yeah.
So essentially, this stuns me because we've talked about this many, many times in the last 5 years. And I pretty said, when are you guys going to do it? You've always been sort of saying, I don't think we're going to. What happened? So Azure Stack, you get a bunch of machines, you get this software from Microsoft, and you are running the exact same software in your data center that they're running. Now, they've got 1 million machines. You probably don't have that. But you can do it with some, I don't know, what's the minimum number?
Yeah, well, let me ask first, how many people have heard of Azure Pack, which is the first step down this path? So a whole lot of you. This is our first step at delivering that cross-cloud consistency, that Azure consistent experience, so that you could write an app and have it run in Azure or on a hoster or in your private infrastructure. And Azure Pack represents our first step. Azure Stack represents our next step, kind of a generational leap in the kind of technology that we're making available based on learnings that we've had over the past few years and some of the technologies that we're bringing out to market. So if you look at Azure Pack, it is a subset of our services, and it doesn't include cloud services, so it does include the fundamental VM PaaS as one example.
Sorry, it does or does not?
It does not.
So I could not build an Azure
You could build infrastructure as a service apps, you could put web apps on there, you could use things like Service Bus and database.
But I couldn't put a cloud service on there.
You couldn't put a cloud service on there.
Oh, that's sad.
So that was one of the limitations. It's sad. So but we've revamped our control plane in hopefully the last major change to the API surface of Azure with the release of Azure Resource Manager, which is a key part of Azure Stack, which is this control plane which is designed around resource groups, kind of a modern cloud application model, designed around a portal, this new modern portal that we have that is also designed around this concept of resource groups. And that will let you create complex apps using one or more resource providers, we call them, or resource types or services that are going to make available as a common core set, a consistent set that will be consistent across on-prem and the cloud. And that set includes storage, networking, which wasn't there before either, compute, which includes virtual machines and scalable virtual machines, what we call scale set virtual machines, which is the foundation for the next type of virtual machine paths that we're moving into, as well as service bus again, and the app service platform as well, which includes web app and mobile apps and logic apps.
So organizations would set up their own service bus. That sounds
as part of deploying this stack, you get that service as part of it. And that was in Azure Pack. Azure Stack includes that as well. So it's including everything Azure Pack did and more, and the modern versions of them as well. The new API surface for Azure.
So maybe in a couple of years we'll see the whole shebang or something like that.
Well, we're actually waiting to get feedback from customers, because it does create this common consistent core, but there's some things that we don't see ever taking to on-prem. So Azure Data Lake, which is a massive scale-out data service we introduced last week, that's really what we believe the cloud is best suited for.
I'm sorry, what does that do? Azure
Data Lake.
What does that do?
It's exabyte scale storage service. So it's designed really for IoT type scenarios, dumping huge amounts of data and then performing MapReduce analytics on top of it. And that's one, or event hubs, which is event ingestion service for the cloud. That one makes sense for the cloud. We don't know if it really makes sense for an on-prem kind of deployment. So this is what we've got to wait for feedback for customers to say, hey, I'm building an application, lots of applications start to take advantage of these services and they want this portability. So that will drive what we put in it.
So that leads to the question that as we get closer and closer to being able to mimic the software that you have in your data center, and clearly that's, we say cloud first, mobile first.
Yeah.
For your coders though, I'm going to say it's more Azure first than server first. Server's kind of getting the good stuff that falls out of the back of Azure, right?
Yeah, that's right.
Which is cool. But if there actually were an Azure stack, if we ever get 100% Azure stack, whether we do or not doesn't matter, wouldn't that essentially eclipse server? I mean, at that point, people were saying, well, what the heck? I mean, server's just a thing that hangs on the end of it.
Well, at that point, it's the infrastructure, right, for Azure Stack. Right. Just like Windows Server is the supporting OS for Azure's cloud as well, everything that we do in Azure. But then when you put your workloads, right, and of course our own services will be built on Windows Server, so even the guests, for example, running Service Bus, those are Windows Server applications. The VMs that you run your own code in, those of course can be Linux or Windows, and same thing in the public cloud as well. Now you were going to ask me a question about scale.
I was going to ask you, so if I wanted to set up my own Azure.
Tomorrow.
Tomorrow, well not tomorrow, I'm speaking, but let's say next week.
Yeah.
Then how many physical machines would I need?
You would need nine.
Nine?
Nine.
Well, yeah?
Yeah.
Okay.
9.
So that's not bad.
Yeah.
What size machines? How beefy these babies got to be?
Well, actually, for point of proof of concept purposes, you can do it with 1. So if you just want to do proof of concept, you can do it with 1. It only needs 64 gigabytes of RAM.
That's not bad.
Yeah.
So you'd be running 9 servers and I suppose that's doable.
Yeah.
Run might not be the verb, but yeah, I could see what you're doing.
Yeah.
Will you have one running in your home? So
Definitely.
No questions about it. Good. Now, Azure's been doing well, and the Microsoft Data Services have been doing well. But an interesting thing happened. December of 2013, in New York, there was this weird thing. It wasn't really a warrant, and it really wasn't a whatever else. They call it a hybrid warrant/subpoena, which sounds scary to begin with. The idea was that there was some guy who had either emails or files that that the Justice Department wanted.
Yep.
And they came to Microsoft and said, we want that.
In Hotmail.
So in Hotmail?
Yeah.
And Microsoft said, oh, type. Well, this person isn't an American citizen, and the data isn't sitting on an American server. It's sitting on a server in Ireland. And the Microsoft guy said, well, we can't do that. And the Justice guy said, why? And the Microsoft guy said, well, they're a different country And we're not even bombing them, so there's a sovereignty issue. And so they said, do it anyway. It goes to court, and I got my notes here on this, was that on 29 April, Judge James Francis says, no, Microsoft, do it, which is astounding. That seems to me, this seems, look, I don't know.
Defies common sense.
It does. It really does. It really does. And then, 31 July, second time around, Judge Loretta Preska upheld it, goes to the Court of Appeals, and it's currently in the U.S. Second Court of Appeals.
And Microsoft has refused to turn it over.
Microsoft's refused to turn it over. Amicus curiae from like, what, Google and Amazon and HP?
We've got the whole tech industry behind this. Brad Anderson and our head of legal counsel has written an op-ed for the New York Times about this and Microsoft's position on it and how bad it would be for the U.S. economy to yield to something like this.
He basically says in this article something like, could you imagine if China came to us and said, we want that data on those servers because we feel like it, So, and it's, anyway, keep your eyes on that, because it feels like to me, and this is my question to you, is that it feels like to me that if the government can do that, doesn't that essentially shut down the American cloud industry?
It does.
Google's based out of America, and AWS is, you are.
I think I'm confident that sanity will prevail here, because it's just the implications of it not. I can't even imagine, really, the effect it would have, the chilling effect it would have on cloud businesses in the U.S. It's not just the clouds that we're talking about, which is where we're going to run apps like infrastructure as a service or platform as a service, but anybody doing a SaaS application that is a U.S. company is going to have a problem.
Absolutely. Absolutely, And it could lead the way for other countries to do the exact same thing, which would be complete insanity. Are you getting any of that now? I know that there are some countries that feel very, very strongly that if their citizens' data or their government's data is on a Microsoft server, that server has to be on their soil. Do you guys get a lot of pushback on that?
We do. There are countries there's countries that feel more strongly and are culturally stronger about this, and the government has regulations that are strict about this. There's other ones that aren't so much. I'll give you an example of one where we're already operating and accommodating the demands of the government. You mentioned it just a second ago, and that's China. So this is a country that says, basically from a cultural perspective, from a business perspective, you cannot operate in China without it being operated and the data being under the control of a Chinese entity. And so this is a place where Microsoft Azure has a public cloud presence. We're the first public cloud to be operational in China, but it's done as an arm's length operation where we do not access the data directly. There's a company in China that is approved by the government to operate the servers for us and the data centers for us. And when we need access for DevOps, for example, to go troubleshoot data, or when we want to deploy updates to our bits or configuration, we do it through them. We get their permission. They know exactly what we're doing.
Wow.
Yeah.
So if it's not your company, and if you don't have any control over it, then how is it a Microsoft Azure thing?
Well, it's running our bits.
But you are collecting some money.
We're collecting money, yeah.
That's good. You guys have been making a lot of stuff open source, So when .NET opens, something the size of .NET goes open source, you imagine who is ever going to sit down and read all that? Yeah. Now, I know that certain countries, and maybe China as well, have said that you can't sell stuff to them without giving them the source code. Yeah. Have you had to give them the Windows source code?
So there's always been a government shared code access policy in place for...
Sorry, say it again?
Yeah,
government shared code access policy?
Yeah, so...
What's that mean?
Well, and I'm not sure if that's the official term.
Oh, okay. Oh, sorry.
Something like that.
It sounded good. It sounded technical.
It did. I made it up as I was talking.
That's what a PhD in computer science will do for you.
So, but this policy has been in place for a long time where foreign governments, China being an example of one that would want it, is saying, hey, we've got a lot of our infrastructure dependent on Windows, and so we want access to the Windows code to give ourselves some assurance that there's no funny business going on there. And so there's been a program with global governments that Microsoft's got in place where the source code is made available to them for inspection.
Wow. Has that ever turned out to be a problem? Do you ever get notes from them? We notice on page 34.
No.
No? Oh, that's interesting. Because the flip side is, whenever I do any work for federal agencies or something like that. There's inevitably a couple security guys in class or on the consulting site, and they'll grab me at lunch and say, and I've heard this for the last 20 years, is that, I don't know if you've ever heard this before, but, our government computers are under constant attack by a certain large Asian country, that the IP addresses are all coming from China. And there's been this undeclared cyber war going on for all this time. Are you guys under attack as well? Are you an interesting enough target that...
We're always under attack. We're just like every company represented in this room is under attack. And
yeah. But there's attack and there's attack,
Yeah.
I mean, who wants to be the first guy to bring down Azure except for the guy who writes license code,
Yeah.
right?
Yeah, we're under attack.
So have you learned anything from it?
Yeah, we have.
No, I mean, that would be a great talk. Like, okay, this is the pattern of attacks we get. This is what it looks like. And that'd be a great case,
it would
case of the
be.
unexplained.
It would be great. Yeah, thanks for the suggestion.
Exactly. That'd be like the biggest case of the unexplained. Fantastic. There's a really interesting technical point. Something I first heard about in Barcelona at the Tech Ed there. We started hearing a lot about containers.
Yeah.
That's the new word now, because Windows 10 has containers, but they're different.
Yep.
There's multiple operating systems inside. Windows 10 has multiple personality disorder in that it's running more than one operating system inside the box, which is kind of cool, So that's a different kind of container. But talk about containers. So containers in terms of, this is a way to deliver server services. It's a deployment tool. I think of it as being like AppV for servers, if that's helpful. But
so how many people have heard of Docker? So it's pretty amazing.
Ask how many of them really understand what it does. Thank you. Me too. I'm like, I kind of got it. So.
Well, so just first of all, it's amazing that many people in this room raise their hands, because we got the raise of hands earlier that there's very few actual developers in here, and yet, so this is an IT pro audience, and everybody's heard of Docker. And Docker, does anybody know how old Docker the company is? 2 years. It just turned 2. This is a company that went from 2 years ago not existing to most of the people in this room raising their hand that they've heard about it, even though you might not have anything to do with it or be using it. The power that represents how Docker's gotten to this kind of mind share is this power of packaging up code and delivering it into an environment where it runs very predictably and has very quick startup. So we talked earlier about agility and this trend towards deploying code very quickly and running it for short periods of time and being able to get rid of it, treating it like cattle, and then spinning up a new container with the same code very quickly. Really awesome for dev test. Really awesome for that feedback loop, that F5 loop we call it, which is developer deploys some code, tests it, doesn't work, deploys other code on top of it, and with these container technology, with a packaging technology on top of it, and with an image gallery. So if you take a look at Docker, it's really taking advantage of operating system isolation technology. It's got a packaging format for the code and configuration, and it's got a global repositories or registries where people can post images of code that developers can take it, or IT pros can take advantage of. It's those three things together, and then the APIs to manage these containers. The benefits that you get, why are containers so fast, is there's a Linux isolation or virtualization technologies called LXC and resource management technologies called C groups. There's a new one called libcontainers, which is also Docker uses, which is virtualization of namespaces like the file system namespace, so that every container believes that it's sitting there on the server by itself. There's process virtualization too. So every container, when you do a PS in it on Linux, you only see the processes that are part of that container. You don't see the processes of the next container over. You don't see the processes of the underlying operating system either. So every container lives in this kind of bubble, which is strongly isolated from this virtualization perspective and from a resource isolation perspective. If you want, you can say this container should only use this much CPU or only should have this much disk bandwidth. So when you have something like that where you kindly control the environment, the code will run the same on your dev box as it will on the monster server in a public cloud, because it's running in an isolated environment, independent, and unaffected by whatever else is running on that server, and unaffected by the code that's in there, unaffected by the configuration there, unaffected by whatever those guys are doing as far as resources. And you get instant startup because you're launching the app on top of an already booted OS, because underneath the container, you're sharing an operating system with all the other containers.
Wait. Okay, so that's a lot. Can I slow you down just a little bit here?
Sure.
Should I slow them down a little bit? Because I was trying to get some of that. But, is this a virtualization tool? If I have 5 containers running, are those 5 instances of Windows Server, or are we only talking Linux? Is Linux doing virtualization different? Is that what I'm saying?
No, it's actually the same. So the Windows Server containers, the same approach as Linux containers.
So every container gets its own virtual machine?
Well, its own virtualized environment.
Its own virtualized environment. So one virtual server is supporting multiple virtualized environments, is that correct?
That's correct.
So what you guys are doing, it sounds like, is that we love Hyper-V, but maybe the walls are thicker than they need to be. And you're saying that if you get everybody to play nice, that it becomes easier to build, am I saying this right when I say a more lightweight multitasking system?
That's right. That's exactly what it is. So what you're hitting on is which containers do I want to put side by side on top of the same shared operating system? And there's a few examples. By the way, dividing up the operating system in this way, you get this kind of agility. You also get efficiencies because you're able to pack, if the container is very small, it launches very quickly into a shared larger container, the virtual machine, but then you can pack a bunch of containers in there together with it. So instead of spinning up a new virtual machine for each one of those pieces of code, then you can share them, you can spin up a virtual machine for all of them and then quickly deploy the containers into them. The question is, when do you need to rely on the virtual machine as a container boundary versus a container boundary like I've been talking about? And the answer is, if the code is trusted, if the containers trust each other as far as the code, they're part of the same security boundary, and they have the same security boundary as the underlying operating system that they're all running on, then it's perfectly fine and safe to generally put them on top of that same operating system. The examples of where that's the case is if you have multiple applications that are part of the same security boundary or trust boundary inside of your enterprise, fine, put those applications in their containers on the same virtual machines. Or if it's an application that consists of multiple containers, multiple tiers or components that you're putting into different containers, of course the application trusts itself, so you can put those on the same virtual machine. But we introduced something called Hyper-V containers too, which we talked about a little bit, and that is aimed at the case where you don't trust the code in the container. And so why wouldn't you trust the code in the container? Great examples in Azure. Azure is a multi-tenant service. We call it hostile multi-tenancy because that emphasizes the fact that the people that are deploying code into our virtual machines, we don't know them, so we can't trust them. They could be anonymous, they could be Russian hackers or Chinese hackers, and so we need to strongly isolate that code and prevent that code from breaking out with a very high degree of assurance into the underlying host operating system or into the next door neighbor's virtual machine. So for that, we've introduced Hyper-V containers, which are the same API, same Docker-compatible API as Windows Server containers, except with an isolation boundary around it that is just as strong as Hyper-V. In fact, it leverages hardware virtualization to isolate the code in that container. The difference besides the isolation, is that you get your own copy of the OS inside that Hyper-V container versus sharing the one that's underneath the Windows Server containers. And that is what allows us to isolate it, because you're getting your own copy, so if you mess with that OS or break out, then you're affecting only yourself, not anybody else that's sharing that.
And all of these containers are the same format? The Docker are the guys who designed the format, is that?
Docker, we've partnered closely with Docker to make sure.
I'm saying that. Is what Docker did to design the notion of these containers?
So Docker really standardized kind of management and packaging and distribution of images for containers.
And how does that make them money?
I think you have to ask them.
Oh, okay, sorry. It's one of those internet things where nobody can figure out how they're making money. Well, I got it, sure.
They're worth a lot of money, but at this point they're a startup.
Got it. So standard Docker container stuff, again, as I said, it's a lightweight kind of multitasking, but you're saying you've got Hyper-V, which is a more traditional kind of multitasking. Is it the same format of containers? So if I might say, I trust these guys, I can throw them into a standard Docker approach with thin walls between them because I'm pretty sure it's good code.
Yeah.
But without changing anything at all, an organization like you guys can say, well, we have to, because we have to not trust them. And so without any trouble,
it's exactly what we aim for, and what we're doing is making it so that it's the same APIs, the same packaging format. So it's a late binding decision. Yeah, I've got a piece of code. Do I deploy it in a Windows Server container or a Hyper-V container? You decide that at the time you deploy it.
So tell me a little bit about the packages. Is this a package as in the same kind of notion as packages that we hear about package managers? I don't know if we have how many devs we have in the room, but in 2010, Microsoft came out with a thing called NuGet.
Yeah.
That was a package. Same kind of solving the same kind of problem?
It is, yeah, it is actually kind of solving the same kind of problem. One of the things you take advantage of in these containers is you build up layers, what they call layers. So on Linux containers, for example, you'll have an Ubuntu layer. So you're on top of a basic Linux kernel, and then you'll say, my application, I'm going to build it on Ubuntu. And then I've got an Apache Tomcat server in there. And I've got then my own code in there. And those are 3 layers. And the way that you spin up, you don't package all those 3 pieces of code together typically, and then ship that in your container. What you do is you launch a container that installs the Ubuntu image, pulls that down from the Docker hub, installs that in the container, then pulls down Apache Tomcat, and then you put your code in there, and then you create an image for your code. And your image depends on Apache Tomcat, which depends on Ubuntu.
So is the image that actual code, or is it just instructions that say, add that to that to that?
The image is the actual code.
It's the actual code, okay.
Yeah. So
this sounds great, though. It sounds like you can essentially build a recipe.
That's right, and you fault it in. So I go deploy my app, and in the image, it says I need Apache Tomcat version blah, 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 and that needs Ubuntu blah, blah, blah. And so the way Docker then goes and deploys it is it goes to Docker Hub, pulls down Apache Tomcat, pulls down Ubuntu, and then launches your code into it.
Now, packaging in Linux is different than it is in Windows, because typically with Linux, these are open source projects. And so they're pulling down the actual source code and compiling it on the fly.
Not in this case. These are binary repositories. So these are Ubuntu binaries that would be up in Docker Hub. And so companies like Canonical and other companies are placing their images in Docker Hub so that their Docker users, container users, can go pull them down and make them part of their images.
So originally Docker was a Unix, Linux-centric thing, correct?
It is, right. And so that's what we worked for them to, first of all, make Docker client work on Windows, and Docker Engine, that's the most recent work, making sure that Docker works on Windows and supports Windows Server containers and Hyper-V containers, working with them to make sure that there's OS-specific APIs to launch containers and set the resource policies. But the Docker Engine is now being updated with GitHub, in GitHub and open source, us working with Docker to manage, to call into those APIs so that somebody can.
You may have to tell them what GitHub is.
Oh, GitHub, sorry. How many people have never heard of GitHub, just out of curiosity? So if GitHub is like the place where all the cool kids put their source code. And so that's where, for example, the core CLR, where we open source that's in GitHub. And that's where we put all our resource group templates. We put those up in GitHub.
Cool, cool. So this packaging method, I assume that it sounds like what I need to do, if I'm a developer, a Windows developer, is that there must be something in Visual Studio that allows me to build my app, and it will then produce a Docker-compatible container. Does that sentence make sense?
Yeah, it did.
Thanks.
Yeah, wow.
I'm checking it out. Yeah. Thank you.
So yeah, there's Visual Studio integration with Docker containers that it's still being worked on, and I demonstrated it at Build last week. So I did a demo in the keynote showing this is, how many people, anybody see that keynote demo that I did last week at Build? And you might have seen similar demos here, which is I took a .NET application and I deployed it into a Windows Server container. Then I take that same .NET application and using Visual Studio, deploy it into a Linux container because we've ported .NET to Linux. So it's the same exact application, except targeted at Linux version of the core CLR. And then I attached to that process, that Linux process, from Visual Studio and set a breakpoint in the .NET application that I hit as I refresh the website that's running in that container on Linux. So that's kind of the deep integration that we're putting into the tooling to support container development.
So the way the dev world, the server-based dev world at the moment is looking like, our tools will generate these Docker-compatible containers. They can be run on just my dev machine, perhaps not quickly, but they will run, and I can see that they actually work.
Actually, they'll run really quickly on your dev machine, too.
Okay.
Yeah, because it's local, and so.
And there's only one person hitting it, as opposed to the thousands that we'll have in the cloud. And then from there, I can upload it to Azure Storage or something like that.
Yeah.
Yes?
Typically, it's a Docker registry is what you'll upload it to. So Docker Hub is the public Docker registry.
So I've got this app, and I stick it somewhere on one of these. And then I go to Azure, and I say, hi, I've got a container. Go run this?
Yep. And here's the image that I need, and it's pointing at Docker registry, and it starts to fault down its dependencies and launches the container.
And when you say Hyper-V containers, does that mean that I, running 2012 R2, could take my Hyper-V and make it able to run these containers?
Hyper-V containers, so this is all Windows 10 and on.
Oh, okay.
Or the new version of
2016.
Server.
I got it.
Version, yeah, Windows Server.
Okay,
I guess
so
we announced the name of it, Windows Server 2016.
I'm just assuming that it's Windows Server 2016 because
Yeah.
Windows Server 10 would seem odd, you know. Maybe just Windows Server 9 just to keep it, interesting. We don't have good beta names anymore. We really need the good, you guys should bring back the good beta names, cities and stuff like that, Anyway, well, so that's good. That's good. You mentioned to me when we talked about something called microservices.
Yeah.
Talk to me about that.
So this pattern of packaging up your code into containers, like I mentioned, one of the things that developers have started to do, and you see this at the kind of large-scale internet companies like Twitter, is to break up their applications into what they call microservices, where a microservice is packaged up and deployed as a container. So the application consists of a bunch of different components that are each developed, even potentially by different teams, that all work together. So this is kind of application delivery as a service. Now each component can be updated independently of the rest. So again, I was talking earlier about the traditional monolithic 3-tier SOA applications. This is the new world of breaking the thing down into fine-grained components, and then you achieve a couple things. One, you get this efficiency of development process because you can work on pieces in isolation, these pieces have contractual APIs. Typically, REST is the API pattern that these application developers use to have these different microservices talk to each other. But you also get efficiencies in terms of the ability to scale them out independently. So instead of scaling out one whole monolithic tier, you scale out just the component that you need. So I need to get a subsystem on my app, and it has higher demand. So I'm going to scale that out. I can also update them independently of each other. So I'm going to update this little component here and leave the rest of it in place. And what people are doing now is focusing on the next layer kind of on top of Docker, which is cluster orchestration, or container orchestration, they call it. So you see things like Yarn and Mesos and Kubernetes and Amazon's Elastic Container Service as this platform that manages containers on top of what they call clusters of resources, virtual machines or servers, figuring out how to schedule those containers. So looking at load balancing, moving containers back and forth when you go deploy a bunch of new microservices, going and saying, oh, I'm going to put them on this virtual machine or that virtual machine, depending on whether depending on the utilization, or this virtual machine or server failed, so I need to go reincarnate those cows over here on this other virtual machine. So this kind of is the modern agile cloud development, breaking apps into microservices. And I think this is the way you're going to see modern application development, so that even down to IT devs, line of business application developers and application delivery inside of IT organizations or line of businesses are going to be moving to this kind of model.
So that all sounds exciting, but that all smelled kind of devy for quite a bit. It was
pretty devy.
Quite a bit. Okay. What does that mean for the nice people in this room?
I thought you would have that answer for them.
Oh, you thought that was my job?
Yeah.
Well, will it affect? I mean, will it make our jobs easier? Will it make them tougher, or will we have to? Okay.
Yeah.
So here's the thing.
Yeah.
What we always look to you is, what should I be learning to keep my job 5 years from now? What is it about containers that we all should know?
Well, so this is uncharted territory a little bit in terms of governance and management of containers. This is really technology rushing ahead of the maturity required to really operate this stuff in enterprise scenarios where you've got governance and you've got controls and you want to keep track of and you're worried about security breaches. And what if a container is breached? Do I have the appropriate audits in place? Can I go back a few days later and understand what that container was doing? Because maybe there was malicious code inside of it, and map that back to the application that launched it. So this is an area that I think is still formative, and one that everybody in here is going to be participating in driving requirements into Microsoft and others that are building solutions for container management at scale. The big difference here is, again, unlike the kind of fairly static environments we live in, a virtual machine, you deploy it, and it's going to run probably for days, if not weeks or months or years. Here, containers can literally last seconds or minutes. And so how do you track the identity of that thing and access of that thing and have forensic information captured for that thing, so if there's something that went wrong, even from a developer perspective, but also from a security perspective, a governance perspective, that you're able to understand what's going on in your systems.
So the logs will be quite large.
I think
you were telling me about that you guys just released a large data service. Will that be for the logs for the containers?
Yeah, actually, that's where so that is the productization of internal technology, where we're dumping all our logs and performing big data analysis over our logs.
So bottom line, keep our eye on containers,
Yep.
look at management tools for them, et cetera. And when the...
Yeah, and I think it's worth mentioning one more thing we announced, and I demonstrated at Build as well, is our own microservice application platform that we've been building and using in Microsoft now, in Microsoft's cloud for 5 years, and it's called Service Fabric. So one of the kind of unanswered areas is application platforms to efficiently manage microservice-based applications. And you see, I mentioned some of these like Kubernetes and others that are aiming at trying to solve this problem, and we feel like we've got a very mature solution here with something called Service Fabric, which is powering a whole slew of Microsoft's Azure services and even Microsoft services in general, from Azure Database to Event Hubs to Cortana, for example.
Amazing. Well, okay, let's move along though, because
we spent
we're still doing the dev. Oh, what? You know that thing.
Yeah.
One of the things we haven't talked really about is identity.
Yeah.
Now, I know a little bit about this, but Active Directory in the early 2000s gave us something wonderful, where all of a sudden we had a directory service that everybody connected to, and by 2004 it was reasonable to really have single sign-on within the organization. Mm-hmm. Now you guys are telling us that we're going to shut a lot of on-premises stuff off and keep one machine running so we can call ourselves hybrid. But what about up in the cloud? I mean, now the problem is that I've got 150 identities on the web, and I somehow don't think I'm going to be using Facebook to sign on to my Social Security location or something along those lines. I mean, can you guys be that trusted single sign-on to the web with something in Azure? I
think that's what we're aiming to provide people, that option, where you can leverage your Azure Active Directory identity as the one identity to access your cloud services. And
wait. Your Azure Active Directory identity.
Yeah.
Where would I find one of those?
Well, it actually could be a projection of your on-premises Active Directory identity. So with Azure Active Directory Federation or directory synchronization, you can have single sign-on experience with your on-premises Azure Active Directory identity to cloud services that are federated with Azure Active Directory. And then we've worked with like 2,400 SaaS and PaaS ISV partners, from Salesforce to Workday to Gmail even, and Twitter and Facebook, where you can, AWS, I think you were talking about you're using it that way, to provide single sign-on service using Azure Active Directory identity to those services. So it is like trying to get rid of this password chaos and management and identity explosion by saying centralize on this identity, and that will be the gateway to cloud services.
And I'm able to get onto my Azure portal.
Yeah.
And if you've ever seen Office 365.
I have a hard time saying that too.
Yeah. Office 365. Then there's a little grid that you click and it shows you all your tools. If I do that when I'm in Azure, then I get, for example, AWS, because I have an AWS account that they do DNS for me. And instead of having to remember the password that's this long and whatever, I just click the thing and bam, I'm in. And it does it for Gmail and things like that. You were telling me that there's something that takes it a little beyond that.
Yeah, so we announced a preview in February. So one of the big pieces of feedback we got with some of these, because there's passwords behind these services, like Twitter. So you've got corporate Twitter accounts, and you want to give everybody in the market, some people in the marketing department access to the Twitter account. You can have that Twitter account behind this federation service in Azure Active Directory such that they're logging in to the Twitter account using their Active Directory identities to a shared marketing Twitter account where they never see the password. And one of the requests that we got is, hey, we want to turn that password over as well and have that password even be auto-generated so it's nice and complex. And so we've got this new service we started previewing in February that works with a number of different services like Twitter, where we'll automatically roll over the password for you. So you never even see the password, it's long and complex. Your users are accessing the service through your Azure Active Directory identity. And one of the things that gives you is control and governance. So the guy leaves the marketing department, you simply remove his access to that shared Twitter account using the controls, and they never saw the password for it, and they can't log into it directly, and now that you've taken away their access through the directory, they're locked out of that Twitter account.
What's that called, this Azure service?
I can't remember what we called that. Yeah.
So if we'll just Google, sorry, Bing.
Bing it. Yeah.
Just
it's Bing. Yeah.
I keep forgetting that you have a blue badge. Yeah. Here's the question everyone wants to know. Where does the word Bing come from?
Do they?
My favorite is that it's an acronym that stands for because it's not Google. So Windows 10 is
Well, you know you can Google that with Bing.
One of my favorite sites is Let Me Google That For You. That's always tremendous fun. So let me put on my economist hat. I don't get to do that often. Let me put on my economist hat and let's talk about where the world's going. I mean, people are going to the cloud. In 2008, you know that I started doing a talk about the cloud because I've been suspicious about it. I worry about security, I worry about do we trust, I worry about reliability and things like that. And I worry about having all my eggs in the one basket. But I immediately knew as an economist that the cloud services would have to be something called a capital-intensive industry. What that means is you spend a lot more money on machines and software and hardware, than you do on people. And we know that industries like that tend to concentrate. So in 2008, I predicted anybody who passed Microeconomics 101 could have done it, but I predicted that we would end up with a small number of large cloud vendors. And what have we got now? We've got Amazon. They're the big dog. There's you guys. And although I think because Microsoft has a broader spectrum of things you do, Amazon's largely virtual machines, which is cool. I don't know anybody developing for Beanstalk, And you've got a bunch of other stuff. I would not think it impossible that you outstrip them in 2 or 3 years. That's entirely possible, okay? Who else is big in the cloud? Well, IBM's making a lot of investments trying to become big dogs in the cloud. Whether it works or not, who knows? Google's kind of doing it, but not really. I mean, they have virtual machines. I think it's just that they have so much compute power that they're saying, what the heck, we'll do it as well. I think it's reasonable. So first of all, we already have an oligopoly. That's the phrase. Oligopoly is where you have not just one big player like a monopoly, but a bunch of large ones. Think of airlines, small numbers. And there's certain behaviors that happen as a result of that. You will see price wars. I predicted price wars. It's true. Amazon has cut their prices like 26 times in the last 2 years, and Microsoft said, we'll match their price cuts. Which makes me wonder, does that mean they were overcharging us the whole time, and now Amazon just made them honest? But in any case, price wars lead to price fixing. So when an industry starts out oligopolistic and there are price wars, eventually everybody decides, crap, we're the big guys, but we're not making any money. And I'm going to say that history proves that there is a very high probability that in the next 10 years, in the cloud service, someone will be indicted for price fixing. And I say that because every single oligopolistic industry does it. What's even better is that they don't have to meet in hotel rooms anymore. There are other ways to do this kind of stuff. And so,
like in the cloud.
Exactly. So, and another thing happens is that once you get a few big dogs.
Where are you going with this, by the way?
I'm almost there. Because we got a few big dogs, there's something called parallel exclusion, which means it's hard for someone else to come in. There was an article in the Times, I think it was, about 2 months ago, about how between Google, Microsoft, and Amazon, like 90-something% of the transatlantic bandwidth had been bought up. So for a new player to come in would be difficult. There's vertical integration. You guys could become an ISP. Any working on that? Anyway, if we end up with a small number of large players, it's almost like the same as a monopoly, And you guys are going to stay in it because you've been doing that. We're all in the cloud stuff. Do you think that Amazon will stay in this? Is it possible that Amazon might be not a player in a few years? I can think of some reasons why,
Why they might not be?
Yeah.
Yeah, well, so I'll tell you what my thoughts on this, and then I'd love to hear yours on this as well. One of the things that I think, if you look at Microsoft as a business, we have no choice. The cloud is our business. It is the platform that we're building the company on top of. And so it is not like it's a diversion, it's not a side business, it is the fundamental to the future of the company. I highlight this in a few different ways. The fact that we are signaling to the world that Azure is the foundation of the modern Microsoft. One way is that a couple weeks ago when we had our quarterly earnings results, we always publish a blog post in the Microsoft blog with those earnings, and that blog post was titled, Microsoft's Growth Fueled by Azure. It started with Azure. And that is an intentional signal of how important Azure is to the company. Another one is that last week at Build, in Satya's keynote on the first day, we're of course doing Windows 10 announcements and Office announcements, but we start the keynote lineup with Satya leading off and then handing it over to Scott Guthrie to talk about Azure, because Azure is the foundation that the other things are built on. So it is really core to the company. If you look at a company like Amazon, their primary business is, of course, retail. It is not cloud. Now, they've pioneered cloud, and they get a lot of credit for having done that and really shown the world the power of the cloud, but that's not their core business. And this is why you see investors have started to make noise about, hey, Amazon, spin out AWS, or at the minimum, give us some insight into what AWS is doing financially so we can understand if we really want you to spin it out from the retail business, because there's investors that are focused on the retail side and saying Amazon thing is a distraction, or maybe it's better if it's let loose on its own, maybe it'd be more successful.
Precisely. But either way, it means that we could have a world in 5 or 10 years where we're very dependent on the cloud and there's only 2 or 3 or maybe 1 big player. That's a little bit scary. I mean, it's sort of, it's great. We're in there because it's saving us money. That's why we came in. If we're smart, we learn the agility. But, well, there's a story like this that you know. It's the 1500s, and people are starving in Ireland because an acre of land could support 2 people, for a year. Well, out of the Americas comes a great idea: potatoes. In 1588, they arrived. And all of a sudden, you could support a family of 5 with an acre. It was fantastic. People were eating 12 to 14 pounds of potatoes a day, and all you needed was potatoes and milk, and you got everything. All of a sudden, poor Irish people were living better than poor British people. Population soared, and by 1887, Ireland soared to 8 million people. Amazing. Of course, you know the next part of the story. Also out of the Americas comes a blight, a potato blight. And it's first viewed in September of 1887. And within 2 months when the crop came in, the crop was half the size. The result, millions of people died. And the population never came back.
I don't like this story.
The population never came back. And to this day, the Irish population is only 4.7 billion. Oh, by the way, guess what? The blight never went away. Here in America, we love russet potatoes.
We have an Azure region in Ireland, by the way.
Yeah, that's... People, we love russet potatoes for French fries. The new blight is actually destroying the russets. So here's the thing.
Okay, I wondered where you were going to land on this one.
So that's what happens when you get a monoculture. That's what it is. A monoculture is when you focus on just one thing. And if everybody were just on your guys. And by the way, you're building great stuff. I mean, when I love to listen to the talks about what you guys are doing with the data center. I always said that if the cloud is a total failure, we will still have a fantastic new set of models for data centers, okay? So what's your advice to us?
Great airplane hangars.
Was it?
And some great
airplane hangars. I think one of those guys said in the talk that you just take the boxcars full of the computers and just leave them in the parking lot. I don't know how that works. But anyway, so let's say that we all go Microsoft. There is that threat. What can we do to make ourselves, well, a little bit sure that should that potato blight spread through the Azure hardware?
So you're asking me what we can do?
Yes.
Well, I would love to have that problem face us.
So you're saying everyone sign on with us and we'll solve it then?
We'll figure it out then.
Okay, that's good. Seriously, is the answer to stay hybrid?
I think that staying hybrid will ultimately cripple you. I mean, the cost of staying hybrid, especially if you've got competitors that are not. And this is what, I think you and I were talking about this, right? When it comes to costs, people throw security out the window. And that is because if your competitors are throwing it out the window and eating your lunch in the marketplace, you really fundamentally, if something is going to cost you money and slow you down, have to be very thoughtful about how you do it to stay in governance but still make money and be competitive. So it wouldn't be great if you were secure yet out of business. Now that's kind of the extreme example, and hopefully
I think that is the example. Yeah. I think the reason that when we were all worried about the cloud, now it's a situation where the CEO says to the CIO, "Hey, all my golf buddies are in the cloud. How come you guys aren't?" And the CIO says, "Well, you got security," and the CEO says, "Do you know they've saved so much money in the cloud that we're getting killed? We are soon going to be the most secure company that's out of business in this organization, in this industry." And so that's why people are going.
Yeah.
So no advice or yes? What do we?
Well, I was just saying, you're responding to your question about staying hybrid, and I think that comes with costs. And the question is that cost going to keep you in business or not when your competitors are not? And as far as the monoculture situation you're talking about, I think that we are a good 10 or 15 years at least away from something like that emerging. And I think that, of course, if I'm still part of this business, have a role in figuring out how to make the planet a safe place in the light of that happening, having very strong security. I do think that some things will evolve naturally. So the rate of change will drastically slow down as things mature and more dependencies are taken on. And that's just fundamentally because it's hard to change when you've got customers, depending on things operating a certain way. Also, when it comes to that kind of risk that you start talking about then of, X% of the world depends on this thing, that you have to be ultra careful about whatever you do. Whenever you change something, change brings risk, and so change will also slow down from that perspective as well. And then when it comes to the other kinds of threats, not just availability and reliability, but also the security risks, of course, very strict security systems. I mean, this is a place where the friction of painful security will outweigh anything else just because there's such, the catastrophic risk of something happening will be so high.
Is it possible, because you guys have had problems like the February 29th problem, which slowly spread around the world, does that mean that, are you looking at, in a situation like that happens again, to be able to throw a switch and say something's spreading, stop it cold? Because
actually,
indeed, if that were the case, then maybe that's one answer.
Yeah, we do have switches like that in place as a result of that. And actually, switches that were in place already stopped that from being way worse than it was.
Oh, really? I didn't know that.
So these are the circuit breakers, and even the stock exchange has circuit breakers too, just for the same kind of thing. A runaway algorithm or runaway trading causes the stock market to spin out of control. There's circuit breakers to stop trading and prevent that from happening. So you're going to see that. You see that in any kind of system like this, especially complex ones where you don't really fully understand necessarily everything that's going on. And feedback loops can develop that you have these circuit breakers to get in the way and stop things from...
We have about 3 minutes left. There's one more question I want to throw you.
Yeah.
Okay, so the cloud stuff you told us is pretty cool. Really interesting stuff. But why you guys?
Why Microsoft? And this one's, I think, an easy one for me. I think I already mentioned Microsoft's commitment just from an existential perspective on the cloud. So we will do whatever it takes to be successful here and to win customer business on the cloud. Some other differentiators from us. If you take a look at Microsoft as a trusted enterprise partner, we understand the enterprise. That's why you guys are here, because you believe that we understand you and that we're going to be delivering what you need to be successful. This is something that other cloud players don't have. They don't have the strong connection with you guys that we do. And the fact that you are using our software and we can help you migrate. We talked about Azure Stack, for example. This focus on hybrid we've got to help you transition to the cloud is something that's going to differentiate us. And then we are ultimately a software technology company at heart. Software engineers like myself, driven by technology to innovate and create things like Service Fabric that I talked about, or Data Lake, or machine learning, and to provide a consistent experience that is suited for enterprise use with compliance and certification and governance, and a common API that wraps everything together. So if you want to eat it all, it provides you a consistent experience. Azure Active Directory being the way to connect everything together. So it's really not just one thing, it's this collection of things. And also, I think, from a partner ecosystem perspective, if you take a look at the synergistic connection and the way that SaaS applications, Microsoft's first-party SaaS like Office 365, drives requirements into the platform to make it better, and also brings an ecosystem with it that is anchored on Azure Active Directory. It looks a lot to me like what Microsoft had in the 90s, was developed in the 90s, that made Server so successful with Server, Exchange, and Active Directory, which was really the back office for almost every company here. And a partner ecosystem came and rode on top of that, and so did we with satellite services on top of that as well. Basically, it's the same playbook we're following now, just at the cloud scale, and all of that stuff is connected in this hybrid.
And it doesn't hurt that you own the operating system.
It doesn't hurt that we do that either. And openness, too, and choice, which is going to make it so that you're not forced because you choose to adopt somebody else's technology, like Linux, like some open source software that's on top of Linux, or another service, another identity provider, another cloud service, that you can't participate or choose Microsoft technologies. And that's why you're seeing Satya and us be so focused on openness and choice.
And with that, we thank you guys. Thank you. Remember to use this knowledge for good and not for evil. And Dr. Russinovich.
Hope you found it useful and entertaining at least. Yeah. Thank you very much.
Otherwise.
Yeah.
Thanks for coming out.